Hi, for the video project, I chose material A, and we're given that the copolymer is nearly symmetric in composition by weight fraction. So, assuming that weight fraction roughly corresponds to the volume fraction, we would expect that the material is either lamellar, perhaps gyroid, or possibly a cylindrical phase. Just from the phase diagram of block copolymer. So right away we can rule out lamellar phase because we don't see that the peaks are in multiples of Q star. So for a lamellar phase, the peaks should be Q star, 2Q star, 3Q star, etc. And they're not. We can also solve for the cylinder phase, and those cylinders will be hexagonally packed, and the reciprocal lattice of a hexagonally packed phase is also hexagonal, with peaks at Q star, square root of 3Q star, square root of 4Q star, square root of 7Q star, square root of 9Q star, square root of 12Q star, square root of 13Q star, etc. We see that more of these peaks overlap with material A, but not all of them. Notably, we don't have any peak for square root of 8Q star that's possible from a cylindrical phase, and we have that in material A. So this leads me to think probably it's a gyroid phase. So there's no way to solve that given the methods that we've been given in class. So therefore I looked to the literature. I found a macromolecules paper from 1994 that was the most useful paper from all the ones that I found. It was a Princeton-MIT Exxon collaboration, and it's called The Gyroid, a New Equilibrium Morphology in Weakly Segregated Diblock Copolymers. To quote the paper, it says, quote, reflections appear at position ratios of square root of 3, square root of 4, square root of 7, square root of 8, square root of 10, square root of 11, square root of 12, square root of 13, and a few more. They list a few more Q star values for the three-dimensional structures with IA3D symmetry. In other words, the double gyroid. This matches perfectly with the data that we've been given for material A. So I'm confident in saying that it's a double gyroid structure, particularly because the results from this paper in '94 have been corroborated by many other people since then. So I built a structure. It's a 1-unit cell structure in a plexiglass cage. Ooh, a bit of glare, sorry. And this unit cell is based on some unit cell drawings given by the Scientific Graphics Project online, which is headed by Matthias Weber, who's a math professor at Indiana University. Yeah, and here's another view. Oh, the glare. It's very cool. I will keep it on my dresser. Okay. Thanks.